So let's get started. All right. So this topic today is going to be building a reverse proxy. Who thinks they know what proxy is? Can you raise your hand? Okay, we have a handful of people. So who knows what a reverse proxy is? Can you raise your hand? Same people I see. All right. So I was gonna make the talk in Go, but then I decided, hey, you know what? Maybe I don't need to show the code. I need to give you the idea. So I decided not Go, but we have part of Go. So everyone has this time, right? You need to choose a username for your email. So I went through this as well, and I went through Gmail registration, and I wanted to put my name. Okay, that's my name, Azam John. And whoops, it's taken. Just like many other names, it's already taken. And what did I do? I did, hey, I can be Azam John too, right? But no, this is not a good email. You shouldn't put numbers in front of your email. Why? Because it's not appropriate, it's not professional. So that's what recruiters say. I wanted to have the same Azam John and the same Gmail. Why do I need this email? I need an email to get to Google, right? So I needed Gmail and Azam John at the same time. How can we achieve this? I wanted Gmail and Azam John at the same time. How can we achieve this? I asked myself. So this is the username, right? This is the domain, which usernames are unique for a domain. That means I can change the domain. For example, to google.com, there's no Azam John at google.com. There was no, but now there is. I work at Google now. Oh, it's been a week. So I wanted this email. To get this email, I need to fix this bug. And what do I do? By the way, it's a dream. It was a dream. It's still a dream. So working at Google. So I had an idea. Can I reverse that? Like reversing is such a cool idea, right? It's like you keep the same words. You keep Azam John, you keep the Gmail, and can we have this? I asked myself. Like you see the pattern, right? Still there's Gmail and still there's Azam John. It's like in terms of the eyes, it's like that. And it turns out you can, because I had the domains. I bought the domain azamjohn.com and connected to a mail server and opened the username called Gmail and started applying for Google, right? So this is something I did that's fun, and decided that some things can be reversed in life. Some things can stay different. This was a part of another project I started, a reverse proxy. We're gonna see why it's a reverse proxy. So more about reversing. Reversing is such a cool problem, right? You're asked during interviews like, hey, can you reverse this? Can you reverse that? I'm gonna ask the audience, can you reverse a string? Who thinks strings can be reversed? Okay, a handful of people. In most languages you can't actually, because strings are immutable, so you can't actually reverse the exact string. You just make another string that's the reverse of the other string, right? So definitely, when you're asked to reverse a string, do not start coding, because just say like, should I do it in place? Should I reverse the exact string? Because in memory, I need to have access to the memory, a pointer or something. You need to be asking a lot of questions, right? It's like, what is exactly you want to achieve? Or reversing an array. This is much trivial problem, right? This is much easier because strings are immutable while arrays are mutable. So you can mutate them. Perfect. So what about linked lists? It gets harder. Can you reverse a linked list? That was a classic problem to get to Google, but now it isn't. Why not? Because it's been asked so many times that they forgot. But I like the idea of like thinking outside the box to reverse stuff. So we're going to look at an example. So I want to reverse this array. How do I do that? So I can use a technique called 2 pointers. So we start from the end, from the beginning, 2 pointers, and then we start flipping them, just like that. So we flip them, and when we reach the same number, what we do, we're done. It's reversed. Easy as that. So how do you reverse a linked list? That's a more challenging problem, right? How do you reverse it? So you may copy to array, reverse the array, and then build another linked list on that, but you won't get the job with that response. So you need to do it in a more unique way. So here's another pointer. We can't go to the end. Why can't we? Because we have to go entire linked list to go to the end of the linked list. So what we do is, as we iterate, what we do is flip its direction from the next to its previous. We keep doing this. And it's reversed. Can you see it's reversed? Because previously, when we started as 2, we'd go through 2, 7, 42, 3, 5, right? But now, if you because it's the new head is a 5, you start with its tail. So it's really, really interesting problem. And here's a question for you. So look that we are changing 7's pointer to 2. What happens to 42? How do we get to 42? How do we get to 42? So we have another variable, right? It's like we keep the pointer not to lose it so that we can switch, keep going. This may be a very boring part of the problem, but we're getting there. So enough about reversing. I'm sorry if you knew how to reverse string, array, and linked list. That's where fun starts. Enough about reversing. Let's talk proxy. What's a proxy? So everyone has their phone, their tablet, their computer, and they're all clients, right? We are clients to some servers. They're servers. What do? You type the name to your browser and press enter, and it connects to the server, asks something. Hey, can you give me this cat picture? Here you are, the cat picture. That's how traditionally request response client server communication works, right? This is very simple. Who initiates the request or the connection? It's the client, right? It's the client that initiates the request to the server. So server responds, and you may be asking, as easy as that? But we can introduce a proxy here. A proxy is something that sits in between client and the server. It receives everything client sends, and it receives everything server responds with. So you make this cat request, for example, and proxy receives this request and sends to the server. And server, hey, I know this response, so it resolves the request and then sends the response back to the proxy, and proxy sends back to the client. Nothing new as this, right? And then we start asking, how can we put the proxy closer to the server or closer to the client? So in this picture, let's say we want to put the proxy closer to this client, right? Client can access different servers, and we put the proxy here. And do you know what this proxy is? It sits before the client and connects to different servers on behalf of the client. Do you know the answer? What's this proxy called? That's very close. It sits on my computer even. I make a connection to this proxy, and I have a chocolate, by the way. Do you want chocolate? I'll give you after the session. Who can tell you? You may use it. You may have it on your phone right now. You know? No. So, it's VPN. Sorry. So VPN is some proxy that sits on your computer, and whenever you want to make a connection, it makes a connection. For example, if you want cheap things, you go to a different country with a different currency, open that website, and it's much cheaper, right, than Poland, for example. So VPN is something we use every day. It's a proxy, and proxies are fun. If you can build a proxy, you know what you can do? You can change the way computers talk to each other. There are proxies that change the world. I can show you that. So, and now let's talk about the reverse proxy. You see how it's reverse a forward proxy, because we see the forward proxy, right? This is the reverse proxy. Reverse proxy sits closer to the server. It's right in front of the server. And then it can take connections from different clients and then respond back accordingly. So I have a $5 DigitalOcean, Google Cloud instance, right? And I run my websites on there. I have different websites. I have, let's say, 42ooze, jprq.io, and azamjan.com. So I have 3 websites. Why do I need 3 instances? Well, I can have one server serve for 3 websites at the same time. And here, Nginx can help us. Have you guys used Nginx? This is the best web server out there. It can work as a reverse proxy. What it does is, it takes the request from the client and looks at the host. Okay, which website do you want? It says, the host says 42ooze or jprq.io, azamjan.com. So the site is which application should receive it, right? That's how Nginx decides for the port number or anything like that. It could be socket file. So Nginx is something that can help you serve different websites from the same machine using the reverse proxy. Easy as that. And we can have another picture. So imagine that we have more than one servers. Why? Because sometimes one website hits so much harder than like any other. That means you need more servers to be able to withstand this load, right? To be able to accommodate the load you're getting. Let's say you have 1,000,000 users. You can technically, but imagine that in your case, you can't serve like 1,000,000 requests at the same time. So what you do is you buy more servers. And at the same time, you have a proxy in here. And who knows what's the name of this proxy? What's it? What's this proxy called? Okay, load balancer. Who said that? Okay, you're gonna get chocolate. So yeah, so this is called a load balancer, and this is so helpful, right? It can set. It can be different, like depending on HTTP or TCP. So depending on the tier you're going to use, you can have different load balancers, and it sits. All it does is receives the connection, is forwards back to the server, and whatever service sends back. Like there are different versions how to choose your server, right? Imagine you have 10 different servers. How do you choose one? So you can say, okay, I can do round robin, like 1, 2, 3, and then when I'm out, like go back, round robin. That's what's called round robin. And you can look at the utilization of the servers. For example, like how much CPU is used for this one, this one, this one, and then choose the one that's idle, or choose the one that's less busy. There are different load balancers. So if you know how to build a proxy, that means you can build a VPN. You can build a load balancer. You can build Nginx-like websites, like to serve different websites at the same time. This is crazy, and this is called a reverse proxy, by the way. That sits in front of the computers, the servers, not the client. So I built something like this. It's also reverse proxy, but it helps you connect to client computers. Can you access client computers? Like, can you access my computer that's serving a website, for example? Can you? Probably not, right? So I built something called JPRQ. This is, by the way, JPRQ server. What it helps is connect clients with each other. Clients can be servers. That's what I decided to change, right? It's like clients cannot be server. Like that does like you can't have Azamjan username, or you can't have Azamjan and Gmail in your email. That's like that. And I decided, no, I'm going to change that. I'm going to change the way computers talk to each other. Make sure that clients can also be computers, like servers. They are computers. So look at this meme real quick. Laugh when you finish. I don't see anyone laughing so far. Okay, so if you explain the joke, it's not funny, but I'm gonna do anyways. So this friend is sending his local host / hi, 3000, right? It's like port 3000. It's like, hey bro, check out this website. And says, looks great, bro. Did he even open the page? Probably not, right? It's like, that's a bummer.
On his computer. Maybe he's running his own local host.
Yeah, exactly. I had another one, but I removed it. It says, like, looks like my website. Yeah. So I wanted to change the way people share their local projects. There's already projects that does that, but I wanted to have the way I wanted to. Have you seen this meme? Like, this is a server. Yes, really, do not close the lid. Computers can't serve. I can tell you there's a computer just like this sitting at home serving people. Like, I'll show you later what the project is, but it's so cool. That's saving me $500 a month for free. You know, it can be this cool. So demo time. So I've talked enough. I'm going to show you how to use the project that I built. So fingers crossed, nothing breaks. I have this Go project. Can you see that, by the way? You don't need to see the code, right? So just a simple website that gives you memes. I run it. It says code is already running, so I don't need to run it again. So what I do is go to localhost 3000. I'm going to change the 8000 to 3000 and hit enter. So it gives me a meme. I can refresh. There's another meme. So you can keep refreshing. Gives you another meme. Cool, right? Can you go to localhost 3000 and use the website? Looks great, right? So I want to give you the chance to do it. So what I want to do is, sorry. So I've already gone through the installation. So what I'm going to do is run JPRQ on port 3000, and I'm going to call this subdomain as a meme. So I requested the subdomain for myself. So if you go to meme.jprq.app on your phone right now, you will see a random meme serving from my computer. Laugh if your joke is funny. So it's random. It's not something I generated. So if it's a meme that you don't like, I'm sorry. So I'll give you a second. Anyone getting their memes? So I'm gonna look at the console to see if someone, oh my God, the server crashed. No, probably not. No, it's running. It was from previous error message. So server didn't crash, it's working. Can you guys see the memes?
Yes.
Perfect, yeah. So now you can share your cool websites. Best one, perfect. So I'm gonna see that meme later. Save it for me, please. So we changed the way computers will talk to each other, right? We decided that, hey, this computer can be a server. So how did I do that? Let me share. And okay, you want to send a message, let's say. So you write down where to send it, right? You send it, for example, the street. You send it to this home address. This is the apartment, and that's the name of the person, right? Without that, you can just make a parcel and send it. You need to say exactly where it should go. The more precise you are, the better. For computers too. So what do you think you need to know to be able to send computer something? What do you need to know? It's IP address, yeah? And the port, yeah, exactly. This is a socket address. Port, from and a port, and to port. Why do I need the from IP port? Because we need to hear back from this. That's why we need both from whom and to whom. This is exactly what we need. And you can send communicate between any computers. So far, I don't see a problem connecting to my computer. You should be able to connect to my computer. You know my IP address, let's say. You should be able to connect, but you can't. Because of the IP addresses. Like, you don't know my IP address, first of all. Even if you knew, we have the same IP addresses because of this thing. We connected at the same routers, and router has the IP address. If you go to like Google and ask what's my IP, you're gonna all of you are gonna get the same result. Why? Because this router has connected, and it has the IP. It receives everything you connect to, like your request from your browser. Everything is received by this router and routes dispatched to you back. How does it do it? For example, this is the IP address. That's the actual IP address of the router you're connected to. And I have a computer with this IP address, and you have a computer with this IP address. Those are actually IP addresses. I'm sorry for exposing them. And you want to receive something from a server, you want to receive something from another server. How do you do that? So we have something like a routing table, if I'm not routing table. Yeah, it's called a routing table. So because we are using this IP address, right, as a public, all of us are using the same IP address right now. But if you send something to, for example, google.com, what in between this router does is that it creates another port and then binds it to your actual port you requested from, and then sends the connection from this public address. This packet will have the public address and the IP of the router that you are assigned to, right? Which data structure, by the way, is the best to handle this? Next time you need to hash. Exactly, yeah. If you have conflict with your manager, use hashmap. Hashmap, yeah, you can use a hashmap to quickly look up which IP address you have to report back. So this probably should be flipped, right? Because you search for what public IP address you have to respond back, and this is it. And you find the computer and just sends back the packet. That's the problem, right? If I'm going to be serving the world with this IP address, I need to tell the router, hey router, anytime you receive at port 80, send it back to me. You need to own the router to be able to do that. You need to know how to configure it to be able to do that. You should not be able to like break this problem, right? There's so many problems associated with having a router. You can say, hey, like my teacher said while I was building the project, my teacher said, like, you know what? I can configure my router. I don't need your project. I said, okay. And then he goes home, and I want to go home, and there's no port forwarding option. So this router doesn't support port forwarding, so some problems cannot be solved. And even if you have the IP address, it's not so easy to share this IP address with someone, right? That's why I built JPRQ. How does it work? You might be asking. This public router. I called it the public JPRQ. It's like join public router quickly. JPRQ. Join public router quickly, and that's how it works. So I have somewhere a server that's running the proxy server, the proxy application, and you install JPRQ, and when you run it, it runs software called agent. I call it client agent. So when the agent is alive, like running, it asks like, hey, can you give me this meme.jprq.app? It's like asks if it's available. It says, sure, why not? So it gives it back the tunnel. So agent knows that it can have this. It's reserved the public address, domain name. So and then your phone comes here and says, hey, JPRQ server, I want to see meme.jprq.app. Can I have that? And what happens is JPRQ server finds a tunnel your agent is running on and sends a message. Hey, JPRQ agent, with the meme subdomain, there's a client who wants to talk to you. And then this JPRQ agent will make a connection to the server and writes the request ID that comes to us, like what was the request it came from, and writes the request ID. And because we have a connection here, what we do is bind this connection together. Just like a proxy, it is a proxy. So whatever is received from this agent is sent back to the client. And whatever client sends back to the JPRQ server sent back to the agent. That's how it works. And it sends back the response. It's like, hey, here's your meme. Enjoy that. Laugh a little. So that's how it works, the public router. You can go to jprq.io and buy me a coffee if you like the project, of course, and start it. So it's open source. If I didn't give you enough details to be able to build your own proxy, come talk after the session. I'll be able to help you more resources, more code. So this is available at azamjan/jprq. So this is a publicly open project, but this is invite only at the moment. If you'd like to use the project, come talk to me after the session. I'll be able to add your username to the allow list so that you can use the project. So this is it. This is, let me talk to you about the use cases. This project has been alive for more than 3 years. People built awesome stuff with this. People became millionaires because of this. I'm not joking. So there was one project, someone hosted an entire radio station using JPRQ. Because it's based on a stream of data, what they did is connected their microphone to their computer and connected that to JPRQ app, and it was live streaming in his website. Isn't that cool? I found it cool. And he requested it especially, because there's two types of tunnels. There was HTTP and TCP. I did have only TCP, and then he was asking, hey, can you add this proxy stuff to the HTTP? And requested this and asked, what are you building? May I ask your use case? And he was saying like a radio station. And then there was one guy who comes and says, you know what? I'm building entire AI training network based on clients, like small computers with big GPUs that's sitting at home, can be utilized. How? Using JPRQ. Why? Because it can expose it as a server, and they can receive and send back to like this host machines, and they can be decentralized in some way. And they're not like decentralized in any way because there's proxy server in between that centralize them. Anyways, they can be accessed publicly. Like any computer sitting at home that has a firewall, that has a router, can be exposed so that you can connect to them. So that was one of the use cases. And there's so many other use cases. I actually built this project for myself. I said, you know what? I'm tired of deploying everything to some instance like a cloud computer. Why? Because it takes so much time, especially in hackathons. I went to multiple hackathons, and What's the problem? I'm a backend engineer, and I have a friend, that front-end engineer friend, and we worked remotely together as a hackathon. And he's asking me, like, is backend ready? I said, no. There's this little thing. But if this REST is ready, can you send me the location? So I decided not to publish it, but instead worked on this project and then shared the link with him so that he can use in his mobile application or front-end application or a watch. There's so many clients out there who can talk to your computer. Like, they're lonely. Your computer has to talk to someone. So yeah, that was the use case. And there's a lot of use cases. I have this computer with me. Can you guess what's the name? You get a chocolate too. Come after the session. So this is the Raspberry Pi. I bought it in 2017. I bought it in 2017 for my first pay from Upwork. I worked in Upwork and get paid, and I had a credit card which I couldn't use, so I had to use it online. So bought it because, like in my country, like we have a different credit card system. Anyway, so I bought this. I couldn't use it. I couldn't connect to it from like Office from anywhere. So I needed something to connect it from. So that's why I built JPRQ. You can expose not only HTTP, because we saw HTTP, right? You can expose anything. Your database, feel free to do so. Or like SSH, fine, right? So I wanted to show you this project. This is called cloud.42.ooze. That's sitting at home, in my apartment. So I can have like access to the computer, right? This is working with JPRQ. It's exposed, and I can connect to it. I can run things, and it's secure. If you go to cloud.42.ooze, it's not going to allow you, but students can. There's like, I ran more than 300 or close to 400 containers into one machine. First, I started using cloud, and the price of the machine that I needed to run 500 containers was like almost like $500. Like so expensive. And I had the bigger version of this as the cluster of Raspberry Pis, so I decided, let me utilize that. So I decided that I would use it as a server, and it's running. And you may be asking, like, how did you achieve the name is different? It's not JPRQ app, right? This is a good question. So I use something called CNAME. If you know name servers, if you know DNS, you can do this. You can buy your own domain name and connect it to JPRQ and just give the CNAME. If you go to like DNS query and like say, hey, what's the CNAME of this? It will say you as like, hey, this is JPRQ app actually. So there's so many use cases, and they're like being utilized in production. This is serving hundreds of people every day. And I'm not sure if you can like run different commands that take longer time. So yeah, you can even stream videos. So in conclusion, let's reach the conclusion. I've been talking so much. So the conclusion is I started this project as a side hustle, and I knew there were projects that already does that. There's ngrok. Have you heard of ngrok? Well, there's a hand of people are like, don't use ngrok. I didn't use ngrok. Why? Because they give you different domains every time you use it. Every time you use it, they say, or session is over, there's a timeout. You can use JPRQ forever. It runs forever. I'm not saying forever, maybe 2 days. So it gives you that, right? The JPRQ is totally free. If you just make an issue like you want to use for this use case, I'll allow you. But in past, it was open to everyone. Everyone who needed to expose their computer, they could do it without asking me. But what happened is some people started using for phishing. Do you know what phishing is? It's like you go to the lake and start fishing fish, right? So what they did is they ran malware on their computer that's identical to Facebook.com, that's identical to Bank of America, identical to some bank sites, and tricked users. Hey, because it started the Bank of America.jpg.app, people see it's like, oh, it has this green icon that says it's secure, right? Is it secure though? No way. It's not verified. It's HTTPS, of course, but it doesn't mean secure. So the domain name, people got fooled. People lost so much money because of this project. People made millions. People lost some money as well. So I have to be honest. So people started using it so bad practices. So they said, okay, I'm going to host like a malicious website. They loved it to do it because it didn't give them the so many limitations as ngrok does, because ngrok doesn't allow you to do anything that's production ready. So in conclusion, so people told me, hey, I'm not going to use, I know how to configure my router. Or there were people who were like, okay, I'm going to use ngrok anyways. Still, this project has already like 1.5 thousand users. I didn't know that there are so many people like me who wanted to use this project. And this project taught me a lot. I have to give the credit to this project to getting me a job at FAANG companies like Facebook, Amazon, and Google, like 3 in a row, just because this project sits on my resume. And maybe it's not that impressive, I must say, but still, the reason that it had so much impact, right? You need such projects in your resume. That's what I'm going to tell you as a conclusion. You need something that actually is relevant, right? It's not the calculator app, or it's not an app that, I don't know, what can it do? It's like Hello World, right? There's something more. You need some more challenges. You need to know how things work underneath the hood. You need to say, no, I don't want this email address. I want to have the way I want it. I don't want computers to just sit. I want them to communicate with other computers. So that's how you do it. And there's so many things. If you want to see such projects, similar projects, first of all, start with your own daily tasks. Like, what do you want to change the way they should change? Why? Because it's you. It's a personal project, right? But if you don't have any ideas, you can go to how to build X. Just type how to build X, or build your own X. I'm sorry, build your own X. And then they will guide you how to do things. For example, version control. Everyone uses Git, right? But someone might say, like, Git sucks, because it does. I use it for a date. Like, you shouldn't store big files in Git, right? And our professor showed us that every time it changes just a line from this hundreds of thousands of lines, Git stores exact copy again and again and again. And just because we had 5 megabytes and we had like 10 commits, we had 50 megabytes of Git folder. If it grows like hundreds of thousands of gigabytes. So you should be careful. And nothing is perfect. JPRQ is not perfect. It's far from perfect. Everything is far from perfect. What it needs to accommodate is your needs, is your own needs, right? Make the project solve your problems. Especially with GPT now, you can automate so many things. Be careful though, because it's not, you don't run a GPT and be able to like connect to your, for example, I have a heater at home that heats up whenever it needs to. It sees the temperature and then it just brings it on and off. And I would allow the AI to do that, because if it's always on, it wouldn't change the world. But it's okay. So be careful, but at the same time, build something that changes the way things work. So that's it. Thank you very much, and collect your chocolates. By the way, if you have any questions related to this project, unrelated to the project, come on in and we're going to talk. So yeah, thanks everyone.